In this video, I'll show you how to control two individual LEDs with an ESP32 using HomeSpan. By the end, you'll be able to turn each LED on and off directly from the Apple Home app. It's a great first step if you're getting started with HomeSpan or want to build your own smart LEDs. The idea is very simple. We're going to connect two LEDs to our ESP32. One on GPIO pin 16 and the other on GPIO pin 17. Each LED will act as a separate HomeKit accessory, so you'll see two switches in the Home app. Let's quickly go over the wiring. Take your first LED and connect the anode, which is the longer leg, to one pin of a 200 ohm resistor. The purpose of this resistor is to protect the LEDs from drawing too much current, so you can also choose a 100 ohm resistor or a 1 kilo ohm resistor. Then connect the other side of that resistor to GPIO 16. Finally, connect the cathode or shorter leg of the LED to the ground. Repeat the same process for the second LED, but this time connect the resistor to GPIO 17 instead of 16. If you prefer, you can also connect these GPIO pins to the input pins of your relay modules instead of LEDs. That way, instead of turning small indicator lights on and off, you could switch real devices like lamps or fans using HomeKit. The code works exactly the same, only the hardware changes. Before we start, make sure you're using the right version of your tools. This is very important for compatibility. So for the ESP32 Board Manager version, use version 2.0.14. And for the HomeSpan version, use version 1.9.1. These versions work reliable together. Some newer ESP32 Board Manager releases may cause issues with HomeSpan 1.9.1, while ESP32 Board Manager version 2.0.14 has proven stable and consistent. You can use newer versions later if needed, but this combination is a great starting point for HomeSpan projects. Now that we have the right version of HomeSpan and ESP32, and we know how to wire the circuit, we can take a look at the HomeSpan code. Let's start with the main code for the ESP32. This code sets up a simple HomeSpan bridge on an ESP32 that creates two independent HomeKit light bulb accessories, one on pin 16 and one on pin 17. At the very top of this code, we include two header files. The first file is the main library that handles all communication between the ESP32 and Apple HomeKit. The second file defines a small custom device class that tells HomeSpan how to control an LED connected to a specific pin. We'll take a look at this code later. Next, inside the setup function, we start by initializing the serial monitor. This allows us to print messages to the console, which will be useful later when setting up Wi-Fi for HomeSpan. Next, we start HomeSpan with the following line. Here we tell HomeSpan that this device acts as a bridge, meaning it can manage multiple accessories under one connection in the Apple Home app. We also give it a display name, in this case HomeSpan Bridge. You can set your own name for your bridge here. Then we define the pairing code. This is the security code you'll enter when adding the bridge to HomeKit. You can change it later, but make sure it's no longer than 8 digits. Now comes the part where we create the actual accessories that HomeKit will recognize. Each accessory starts with Span Accessory. Think of Span Accessory as one complete HomeKit device. It could be a light, a switch, a sensor, etc. Inside each accessory, we first add an accessory information service. This provides HomeKit with some basic details about the device, like its name and type, and it also enables the identify function, which HomeKit uses to confirm that the device is responding. After setting up the accessory information, we can add our custom LED device. This creates an LED accessory on pin 16 of the ESP32. The logic for controlling the LED lives in DevLED class we defined earlier. We then create the second accessory in the same way, also with a new span accessory and identify function. And lastly, we call the HomeSpan function in the loop. This keeps HomeSpan running in the background. It constantly checks for new HomeKit commands and updates your accessories when something changes. Without it, the ESP32 would stop responding after setup. Now that we understand how the main code sets up the HomeKit bridge and accessories, let's take a closer look at the second file. This file defines how a single LED behaves as a HomeKit light bulb accessory. It's basically the part that tells HomeSpan what to do when you turn a light on or off in the Home app. We start by creating a new structure called DevLED, which is based on the Service Lightbulb class from HomeSpan. That means our LED will appear in the Home app as a standard light bulb that can be switched on and off. Inside this structure, we define a variable called LED pin, which stores the pin number the LED is connected to. We also create a variable called power, which represents the on/off characteristic that HomeKit uses to control the light. In the constructor, we tell HomeSpan that this device supports the on characteristic. Next, we save the pin number and set that pin as an output using pin mode. We also print a short message to the serial monitor, so we can confirm that the LED was successfully initialized. Then comes the update function. This function runs automatically whenever HomeKit sends a new command. For example, when you tap the switch in the Home app. Here we check whether the new value is on or off, and we write that state directly to the pin using digital write. If the light should be on, it sends a high signal. If it should be off, it sends a low signal. We also print a short message to the serial monitor to show what happened. And that's really all this file does. It connects the virtual HomeKit light bulb in the app to the physical LED on your ESP32. So every time you create a new dev LED in your main code, you're creating another fully functional HomeKit light that controls a real LED pin. This also means that this code is fully reusable in other projects. If you want HomeKit to show a switch icon instead of a light bulb, you just need to change the type of surface you're using. In the LED version, we use surface light bulb, which makes HomeKit treat it like a lamp. To turn it into a switch, simply replace surface light bulb with surface switch. Everything else works the same. The on characteristic still controls the on and off state, but now the accessory will appear as a standard switch in the Home app. Now that the code is uploaded to the ESP32, let's move over to the serial monitor. HomeSpan includes a built-in command system that lets you manage everything, things like Wi-Fi setup, data resets and device information without ever touching the code. When you open the serial monitor at your specified baud rate, you can type certain letters to trigger different functions. If you type a question mark, HomeSpan will show a full list of all available commands. That's really useful if you ever forget what options are available, or just when you want a quick reminder. Before we start setting up Wi-Fi, we'll do a quick cleanup to make sure we're starting from nothing. Typing E will erase all stored data and restart the ESP32. This is a good way to clear out any leftover information from previous tests or configurations, basically giving the board a clean slate. If you ever need to completely reset everything, you can also type F for a full factory reset. That removes all stored data, including Wi-Fi credentials and pairing information. I'm not doing that right now, but it's good to know it's there if you ever need it. Once that's done, we can move on to connecting Wi-Fi. Type W in the serial monitor to start the Wi-Fi setup process. This can take a little while. You'll be asked to enter your network name and password. And once that's done, the ESP32 will remember it so you don't have to set it up again next time. Now we're ready to pair the device with the Home app. Open the Home app and tap the plus icon, choose Add Accessory, and then select More Options. After a few seconds, you should see the HomeSpan bridge appear in the list. Tap it, wait for it to connect, and enter the pairing code we set in the code. In this case 111-22-333. If for some reason your ESP32 doesn't show up when you're trying to add it, type U in the serial monitor. That command unpairs any existing connections and basically tells HomeSpan to forget about any old pairings. It's a quick fix if your device was already connected to another iPhone or Home before. If you found your ESP32, follow the steps you see on your HomeKit screen, and if everything is done correctly, you should be able to see both LEDs appear as separate light bulb accessories in the Home app. Now you can turn them on and off independently, and if you look at the serial monitor, you'll see messages showing exactly which LED turned on or off. Each time you toggle the switch in the Home app, a command is sent to the ESP32, and the LED responds instantly. And of course, if you had a relay module connected instead of LEDs, the exact same thing would happen, but now you have switches in your Home app instead of light bulb icons, so it looks better when you're controlling relays. Right now, the LEDs or relays will only respond when your iPhone is connected to the same Wi-Fi network that the ESP32 is using. That's because HomeKit communicates locally over your home network by default. If you want to control your device from anywhere in the world, you'll need to set up a Home Hub. That can be an Apple TV or a HomePod. Just make sure that your Home Hub is signed in with the same Apple ID you used for the Home app, and that it's connected to the same Wi-Fi network as your ESP32. Once that's done, HomeKit will automatically route all commands through your Home Hub, allowing you to turn your lights or relays on and off remotely, even when you're far away from home. And that's it, you now have two independent HomeKit accessories running on your ESP32 that you can control directly from your iPhone. If you'd like to see more HomeSpan tutorials, for example how to add a temperature and humidity sensor to your setup, let me know in the comments. If enough people are interested, I'll make a full video showing exactly how to do that.